Welcome to lesson number 2. We're going to be looking at analyzing quadratic functions and equations. So a quadratic function is any function that has the that can be written as ax squared plus bx plus c equals 0. And the only restriction is that a cannot equal 0, because if it did, then it would no longer be quadratic, because it would not have a degree of 2. For it to be a quadratic function, it has to have a degree of 2, so this exponent of 2 here. Now what we're going to be looking at in this lesson is transforming our equation ax squared plus bx plus c into y equals a times x minus p squared plus q, and a is equal to 0. And we're going to be looking later on at what the p and the q parameters are on our graph as well. But today we're going to be looking at how these parameters actually transform our graphs. So here I have the graph of y is equal to x squared plus q. And if we look at x squared plus q here, if we were to put this in our calculator, all we're actually doing is inputting f of x is equal to x squared. So if I plug in x squared in my graph, I get something like this. But what I'm going to do is make sure that your graph is in standard window settings, and you should get a graph that looks like this. F is equal to x squared. Now what we want to do is write an equation which represents each of the following. So y is equal to f of x plus 3. Now we know that y equals f of x, which equals x squared. So x squared is equal to f of x. So all I need to do here is substitute my value, or my variable of f of x, my function here, with x squared. So y is equal to x squared plus 3. And I would do the same thing over here, where y is equal to x squared minus 3. What we then want to do is use our graphing calculator again to sketch y is equal to f of x plus 3 and y is equal to f of x minus 3 in our grids. So if we plug this into our graphs, I have x squared plus 3, then it's going to go up. I have another graph that I want to graph, and that's x squared minus 3. So x squared minus 3, graph that, and now it's moved from the origin down 3. When we had y is equal to f of x, remember y was equal to x squared. That's what the function represents. Our vertex was at 0, 0. The vertex is the bottom or the middle of our graph here. This is called a parabola. So if we look at the vertex was at 0, 0. The minimum value, so the lowest value, was y is equal to 0. And our equation, or axis of symmetry, if we were to cut this in half so it's equal on both sides or symmetrical on both sides, my value of x would be equal to 0. And that was my original, so that we didn't transform that at all. We just left it the same. However, with f of x plus 3, this became y is equal to x squared plus 3. That changed where my vertex was. So plus 3 went from the x value of 0 and the y value up 3. So now we're at 0 and positive 3. This still has a minimum value. So a minimum value, but now our minimum value is equal to 3. Right here, that's our minimum or maximum value is going to be equal to the y value at the center of, or at the axis of symmetry. My axis of symmetry hasn't changed. If I were to split this in half, it's still going to be x is equal to 0. But we could say that we had a vertical, it went up 3 units, a vertical translation, 3 units in the upwards direction. Now with this next function, f of x minus 3, y equals f of x minus 3, y is equal to f of x, which is x squared minus 3. And this is going to be the reverse of the this previous function. So now it has a minimum of -3. Axis of symmetry is still the same. And this time we had a vertical translation, 3 units down. So if I add q, this results in a vertical translation. And so here, y is equal to x squared plus q, where this is where my vertex would be 0 and q, and this would result in a minimum value of whatever that value of q is. And so a vertical translation of q units, in this case because q is positive, up. So what is the effect of the parameter on the graph of y equals x squared plus q? This moves the graph up or down q units. Compared to the graph of y equals x squared, the graph of y equals x squared plus q results in a vertical translation of q units. So if q is greater than 0, so like 1, 2, 3, so positive numbers, then the graph moves up, and if it's less than 0, then the graph moves down. So our original graph is still y is equal to f of x is equal to x squared. And so here I have x squared represented. We want to write an equation which represents each of the following. So y is equal to f of x plus 3. Now remember, f of x is equal to x squared. And so when I input x squared here, we're going to have x plus 3 squared. For this one, we're going to have y is equal to x minus 3, but that's squared. So this, everything in the brackets is taking my x value, and since f of x is equal to x squared, then we have to square everything in the brackets here and here. So just like last time, what we got to do is graph these. And so my original function was x squared. But now we've changed things slightly. In brackets here, I have x plus 2, or no, x plus 3 squared. Now watch what happens. My graph moved to the left 1, 2, 3 units. So now instead of being at my origin, my graph is 1, 2, 3 units to the left. So what do you think is going to happen with y is equal to x minus 3 squared? So x minus 3 squared? Well, let's take a look. X minus 3, close my bracket, and square. We've moved to the right 3 units. So 1, 2, 3 to the right. And so now it looks something like this. I'll match. With the highlighters, I'm just going to match the equation with their graphs. So that was x plus 3, and this here is x plus 3, x minus 3, just like we did previously. Here was my original, just like before. But now when I have x plus 3, and this is squared, remember that was squared in our brackets, then there was, oh, sorry, I guess the function itself is not squared, forget about that. So when I had x plus 3, if we compare that to our previous function, y is equal to x squared, this then became y is equal to x plus 3 squared. The vertex changed, so the center of my parabola changed from being at 0, 0 to now being at -3 and 0. So my x values changed. It still has a minimum value, but it still has a minimum value at 0. Remember, look at the y values there. However, my axis of symmetry is no longer 0, it is now -3. Because if I wanted to cut this in half, I would have to cut it in half at my x value of -3. So here we had a horizontal transformation and a translation. So we moved it. When we are moving something left, right, up, or down, then we're translating it. So horizontal translation, 3 units left. With this other one, we had y is equal to x minus 3 squared. And note how my vertex changed from being at 0, 0 to positive 3 and 0. So when this was negative, it made it positive. Still has a minimum y value of 0. But now my x-axis, or sorry, my axis of symmetry is at positive 3. So resulting in a horizontal translation. 3 units right. So if I have y is equal to x minus p squared, this is going to result in a vertex of whatever p is, and if it's negative, it'll be positive, 0, and a minimum still of 0. And my axis of symmetry is going to be at my value of p. And so we're going to have a horizontal translation, p units. If p is positive, or sorry, if p is negative here, then that's going to go towards the right. And so what is the effect of the parameter p on the graph? Well, we pretty much just answered that right here. But whatever p is, that's going to move horizontal units right. Compared to the graph of y squared, the graph of y is equal to x minus p squared results in a horizontal translation or shift of p units. And if p is greater than 0, so a positive number, then your graph will move towards the right. If p is less than 0 or a negative number, then it moves to the left. All right, now we're going to be combining p and q. So write an equation which represents f of x plus 2 minus 4. So here we go. We have y is equal to x plus 2 if f of x is equal to x squared minus 4. So predict the transformations on x squared in A. Use a graphing calculator to verify the results. So here we have a horizontal translation. So horizontal translation, and that's going to be going 2 units to the left. So 2 units left. And we also have a vertical translation, and this vertical translation is going to be 4 units, and because it's negative, that's going down. 4 units down. Now, we're supposed to use our graphing calculator to compare. So that was x plus 2 squared minus 4. So the first one going to pop up, that's my original. And then we moved over, 1, 2, and then we went down, 1, 2, 3, 4. So 2 units to the left, check. 4 units down, check. All right, so my new function was y is equal to x plus 2 squared minus 4. My vertex now is at -2 and -4. So -2 and -4. If we look at this, that is found in our equation. This is the equation of our vertex. Now we have a minimum value of our y-axis, or of our y coordinate of -4, and an axis of symmetry of -2. And so here we had a horizontal translation, 2 units left, and a vertical translation, 4 units down. And I'll leave this for you to fill in, and then I'll check it in class.